On parallel lines and transversals. Firstly, parallel lines are coplanar lines that do not intersect. We have an example here showing it that we have these two lines, lines AB and line CD, that are going in the same direction. Basically, are never going to meet. They never will meet, even however far you extend them. They're just never going to cross each other. Now, the way that we know this is by these little arrows drawn here. So an arrow can actually is used to indicate that the lines are parallel. You see the arrows like this. You can also see arrows written more like this. You might see multiple arrows saying, like, you have two arrows like this. That means those two are parallel to each other. Now, it doesn't matter what you have. If it's two arrows, the ones with two arrows are parallel to the other ones with two arrows. If it was four arrows, it would be parallel with ones with four arrows. Basically, they just match up the same. Now, when we're actually talking about the notation of these, the notation of this is line AB is parallel to line CD. Now, this little looking like an 11 is actually two lines going up and down, meaning parallel. Now, however, lines are not the only thing that can be parallel. You can also have planes that are parallel to each other. What a parallel plane is whenever the planes do not intersect each other. So basically, the planes are going in the same direction. It's just the same as parallel lines, but instead of being lines, we're dealing with planes. Now, to note this, we can just say, like here, plane J is parallel to plane K. Alright, moving on to the other one, there is another type of line that does not intersect another line, but these are the ones that are not on the same plane. They would be called skew lines. So what a skew line is non-coplanar lines that do not intersect. And it's a lot easier to just actually look at the picture to figure out what we're actually talking about here. So, to start off here, we've got an example of being PS and VR. So let's look at where PS is on the picture, and we're going to look at where VR is. Notice that these two lines are going in different directions of each other, but they're never going to cross. Even if we actually continued the line PS on in the background, it looks like it might cross. However, you got to realize that that's in the background. It's going in a different direction. VR is already basically there in the same plane that S is. So whenever you have this little line continuing in the background, it's not actually crossing. Now, there's other ones that can be done on here. So we have another example. We got TW and UQ. So TW is the top line here, and UQ is another line that's going up and down. Again, it's pretty much the same story as the other one, it's just they're going in different directions. And lastly, we can see the same thing done with PT and QR. PT goes up and down, QR is on the side across from it. Right. But there's other ones that are on this picture. We just don't need to use this to cover every single one of them. Basically, they're just lines that go in different directions and will never meet each other. Let's look at example 1. A says, name all segments parallel to segment AE. So let's look at where AE is. It's this line going up and down. So for it to be parallel, it has to be pretty much going in the same direction as AE. So we can just look at our picture and find three other lines here that are all just still going up and down. Those are the ones that would be parallel. Alright, the first one we did was HD. The second one was FB. And the third one was GC. So all three of those are the ones that are parallel to AE. This one says it wants to give two examples of parallel planes. So we're going to just end up picking a plane, and then we'll figure out which one's parallel to it. So I'm going to start off with the one on the left side. Alright, and if you recall, when you're naming a plane, you would say plane and then just pick 3 non-collinear points that would form, basically are 3 points that form a triangle on it. And you can pick any of these 3 points because they would all work. We're going to go with H, E, D. So plane HED, and we need another plane that is going pretty much in the same direction. The only plane that on this picture that's going the same direction is the one across from it, and that can be named plane. Pick 3 points from it. We'll go with GFC. Alright. And they want another example of this, so we'll just pick another plane to start off with. Let's just start off with the one in the front, and we'll call this one plane ABE. So we got plane ABE here, and then we need to figure out which one it's parallel to. So if it's the front, we're going to be parallel to the one in the back. And again, we just pick 3 letters that are on that side. So that would be plane. We'll go with GCD. Alright, now for the last part of this, we're wanting to know which part is skew to GH. So look at where GH is. We've got GH here at the top. So we need everything that would be going pretty much in a different direction of GH and does not intersect it. So it's a matter of just looking through it. We've got AE here at the front, FB here at the front, AD, and BC. Right. Now, the other ones that we have here, HE would intersect at H, HD would intersect at H, GC would intersect at G, GF would intersect at G, EF is the same direction as HG, so that's not skew. That would be parallel. DC would also be parallel, and the same thing with AB. So these are the only ones that actually work here, and again, those would be EA, AD, FB, and BC. Alright, for 2A, it wants to name all the segments parallel to JK. So JK is here at the bottom. We need it to be parallel. So that means it's going to be on the same plane, but does not intersect. So really, we're just looking for things going in the same direction. Now, there's only one line on here that's actually going in the same direction as JK, and that would be OP. So that is our only parallel line for JK. Moving on to the next example, we have to name all segments parallel to NS. So NS is this line here. So we need to know all the other ones that are the exact same direction. So we've got MR, LQ, KP, and JO. And we're just going to name it that way. MR, JO, LQ, and KP. So those are all the ones that are parallel to NS. Now moving on to the next one, we've got to know a plane parallel to JKL. So now we're worried about the plane JKL, the one that has all 3 of those, would be this pentagon here in the front. So it to be parallel, it has to be going in the same direction, and there's only one part that goes in the same direction, and that's the other pentagon in the back. So in order for us to name the shape, we need to pick 3 letters that form a triangle, which could be any of them. So I will go with plain POS. Alright, then that takes us to the last part on this problem, and it names 4 segments skew to RQ. Alright, we can actually do all of them on here, but just 4 is what they were asking for, so RQ's here. So, needs to be going in different directions and will not be on the same plane. Okay. So that eliminates anything on this pentagon. So we're not worried about anything there. Now we have to figure out things that would not be going in the same direction that are not on that pentagon. So we got NS, JO, and KP. We don't have MR because that intersects at R, and LQ because that intersects at Q, so we have those ones. So we'll just write those ones down for now. NS, JO, and KP. And then we also have a couple more that we're going to work with that are on the other pentagon. Okay, it can't be LM because that's parallel. So NM, JN, JK, and KL. Those are all other ones that will be skew. So NM, JN, JK, and lastly LK. And those would be the ones that would be skew to RQ. Moving on to the next page, now we're talking about a transversal. So what a transversal is a line that intersects 2 or more lines. So we look at this picture here in the middle, and we've got lines T, L, and M. The line that goes through both of the other ones is line T. So line T would be our transversal. Now, whenever these lines intersect, they actually make 8 different angles in it. Now there's specific names for certain ones based off of their location. And we're going to end up looking at exactly what you call each of these, and these are going to be important for your actual next test. So the first thing is corresponding angles. So for corresponding angles are angles that are on the same side of the transversal in the same position. Basically, they're going to be in the same spot. That's the easiest way to remember it. So notice here, angle 1 and angle 5 are both in the upper left at both of the intersections. So those are in the same spot. They're actually corresponding angles. Angle 2 and angle 6 are in the upper right. Angle 4 and angle 8 are in the bottom left. And we have angle 3 and angle 7 in the bottom right. Okay, the ones in the same position are corresponding angles. Takes us to the next example, which is alternate interior angles. So when we're talking about alternate interior angles, there's a couple of key words that we're actually looking at. First off, interior. Interior means on the inside. So we're worried about angles on the inside, so that kind of eliminates 4 different angles here. We're only worried about angles 3, 4, 5, and 6. Now the second key word on here is this alternate. Alternate means different, or just a different way of looking at it. So what the alternate tells us is we're going to have different sides. So alternate interior angles are angles on the inside of the 2 lines being intersected, but on opposite sides of the transversal. So that being, for example, 4 and 6 are 3 and 5. They're on the inside but opposite sides of that transversal. The next one uses almost the same keywords except changes one little part about it. Instead of being interior, it is exterior. Alternate is still the same. So instead of worrying about the angles on the inside, now we're going to be talking about the angles on the outside. So if we're looking at this, alternate exterior angles, we'll worry about the angles on the outside, so that would be 1, 2, 8, and 7. The alternate ones would be 1 and 7 because they're on opposite sides, and then 2 and 8 because they're on opposite sides of that transversal. So again, alternate exterior, outside, opposite sides. Now the last one is called here consecutive interior angles. Alright, now I normally will call this something else, and most of the time when we're going to refer to it, we can refer to it the same way. I call it same side interior. It makes it a little bit easier because now we know exactly what we're talking about. While alternate was on the opposite sides, same side means they're on the same side. So if we're actually looking at this picture, we're only worried about the ones on the middle and on the inside. So 4 and 5 would be same side interior angles. We also would have 3 and 6 that would be same side interior angles. Now, again, inside, same side is same side interior. Or you can call it consecutive interior. Either way will be the same. Alright, just a quick recap. Corresponding angles are angles in the same position on both intersections. Alternate interior angles are angles on the inside of the intersections on opposite sides of the transversal. Alternate exterior angles are angles on the outside on opposite sides of the transversal. And same side interior are also considered consecutive interior, are angles on the inside on the same side of the transversal. For these examples, I want you to name the angle relationship. If there is none, you will put no, or none. Alright, so first off, we got 1 and 8. So, we're looking at here, 1 and 8. The transversal is R. Alright, 1's on the outside, 8's on the outside. They're both on the outside. 1's on top, 8's on bottom, so they're on opposite sides of the transversal. So if they're on outside, opposite sides, that is alternate exterior angles. And I'm abbreviating it. It would make it a lot easier than have to write it out. Alt X angle. Moving on to number B, we got 2 and 3. So 2 and 3, top, top. Both on the inside. Since they're both on the inside and both on the same side of that transversal, that would be same side interior angles, or you can call it consecutive interior angles. But again, I'm normally going to refer to it as same side interior. Moving on to the next problem, we have 5 and 7. So 5 and 7. Right, 5 is on the bottom left, 7's on the bottom left. Since they're both in the same position, that is corresponding angles. Moving on to D, we've got 2 and 7. 2's here, 7's here. Both of them are on the inside. Since they're both on the inside, we have to figure out which side of the line the transversal are on. 2's on top, 7's on bottom. Opposite sides. So, alternate interior angles. Going for E now. We got 1 and 3. So, with 1 and 3, 1's here, 3's here, both in the upper left. Since they're both in the same position, that is corresponding angles. Last one on example 1 is 6 and 7. So with 6 and 7, we got 6 here, 7 here. They are both on the inside. They are both on the same side of the transversal, meaning they're on the bottom. So that would be same side interior angles. Or you can call it consecutive interior angles. Now we're going to look at example 2. Now there's a little bit more here. Instead of having one transversal, they're all technically a transversal because they all go through two different lines. Okay. Now, key on this is to figure out which one is the transversal that we're talking about. In order to identify the transversal, it has to be touching both of the angles we're talking about. And in order for these to have the exact same, or to be one of these names, it must be on the same transversal. So angles must be on the same transversal for you to have that name. So starting off with the first one, we got 5 and 13. So we got 5 here, 13 here. The transversal that they are on is line B. Notice that 5 and 13 both touch line B. 5's in the upper left, 13's in the upper left. So that makes them corresponding angles. Moving on to B. So with B, we've got 7 and 14. 7's here, 14's here. Once again, they are on line B for our transversal. So line B is our transversal. 7 and 14 happen to both be on the inside. Right? 7's on the left, 14's on the right. So, since they're on opposite sides of the transversal, they are alternate interior angles. Moving on to C, we got 3 and 6. So we got 3 here, 6 here. They are both on this top line, which they labeled A, B, D. They forgot to actually label that one, but I'm assuming it probably should be C. Okay. If we only worry about that line, 3's on the outside, 6 is on the outside. 3's on the bottom, 6 is on top. So that would be alternate exterior angles. Moving on to D, and with D we have 9 and 16. So 9's here, 16's here. They both are on line D. So line D is our transversal. We're only worried about on that line, so we don't really even look at the top. 9's on the outside, 16's on the outside. 9's on top, 16's on the bottom. So they're on opposite sides of the transversal, and they're on the outside, so our answer is alternate exterior angles. Alright, moving on to our next example, we have 4 and 7. So 4 is here, 7's here. Again, we decided to name that top one C, so we're going to keep it that way. Alright, they're both on C. They're both on the inside. They're both on the bottom. So this is same side interior angles, or we can call it consecutive interior angles. Moving on to F, we've got 2 and 10. So 2 and 10, 10 here, 2 here, they're both on line A. Line A has it where 2 is on the top right, 10's on the top right. Since they're in the same position, they are corresponding. Alright, takes us to the next one, which is G. So for G, we have angles 8 and 14. So 8's here, 14's here. They're both on line B. Okay. 8's on the bottom right. 14 is on the top right. So they're both on the inside. They're both on the same side. So that would be same side interior angles. Letter H, 6 and 11. So 6 here, 11's here. There's not a line that, however, goes through both of them. So there is not a transversal connecting it. Since there is not a transversal connecting them, we cannot name it anything. So our only possible answer here is none. There's not any way we can connect those. We're going to go with the next one real fast, and we got 4 and 13. 4 is here, 13's here. Again, there's not a line that connects both of those, so our answer is none. Right, and then our last one here is 4 and 9. So 4 is here, 9 is here. They're both on line A. Right, 4 is on the inside, 9 is on the inside. 4 is on the right, 9 is on the left, however. So they're on opposite sides, both on the inside, so your answer is alternate interior